1.5, parallel lines and transversals. So we know that with parallel lines, they're never going to touch, they're never going to cross, they're never going to intersect. And so we're going to start with looking at what's called a transversal. Transversal is just a line that intersects two coplanar lines at two different points. Doesn't say anything about parallel just yet. We'll get to the parallel part in a minute. But just so that you can see, if you look here at the highlighted line, line Z, that line is a transversal because it's cutting through both lines X and Y at the same time. So up here at the top in the diagram, let's just make a note to ourselves that line Z down below is an example of a transversal, okay? All right, so when you're looking at transversals, it cuts these lines into 8 different angles and special relationships are formed. And so the first thing that we're going to look at is whether angles are located in the interior or the exterior. And we know what that means, inside and outside, but let's look at it in terms of some lines here. So I'm going to highlight the word interior, and the interior part between the two lines is this section here in pink. Okay, so angles 2, 6, 3, and 7 are all in the interior. They're between the two lines. Then when we go to look at exterior, I'm going to highlight that in green. That is everything on the outside, so up here and down here, which means angles 1, 5, 4, and 8 are all in the exterior. Another relationship that they have is that they are either located on the same side or opposite sides of the transversal. So same side or opposite side of the transversal. So let's look at this for a second. If we look at angles 1, 2, 3, and 4, they're all on the left side of the transversal. That same side. 5, 6, 7, and 8 are all on the other side. And so when you go to talk about opposites, then we're looking at something like angle 2 and angle 7. Angle 2 is on the left, angle 7 is on the right. When we go to compare these angles or talk about the relationships today, we're not talking about angles like 1 and 6. We've already talked about those. Those are vertical angles. Same thing with 1 and 5. 1 and 5 are a linear pair. We've already discussed that relationship. We're talking about an angle from the top 4 compared to the bottom 4. So like angle 2 and angle 3. One from the top, one from the bottom. So let's look at the vocabulary here, and we're going to go back and forth a little bit to that picture. The first one we're going to talk about is alternate interior. Alternate is just a fancy word for opposite, and we talked about opposite on the past page or the previous slide, and you can see the word opposite here. So we have a pair of non-adjacent angles that lie on opposite sides of the transversal in between the other two lines. So we're talking about they're opposites and they're on the interior. So if we go back to this picture for a second, we can see that angle 2 and angle 7 are alternate interiors. They're on opposite sides and they're both in the interior. Same thing with angles 3 and 6. So angle 2 and 7 and angle 3 and angle 6. There's two different examples there. They're opposite sides and they're both in the interior. Now we go to the next one, alternate exterior. Again, alternate means opposite. And now we're looking at the exterior. So let's look at the picture again. Alternate exterior. 1 and 8 are alternates. 1's on the left, 8's on the right, and they're both in the exterior. 4 and 5 are another pair. So 1 and 8, angle 4 and angle 5. Alternate exterior. So again, alternate means opposite. Now we're going to switch to the word same side. So same side we know is the same side of the transversal, both left or both right. And we're going to look at the ones that are on the interior first. So if we go to our picture here, same side, interior, we can see that angle 2 and 3 are both on the left and they're both on the inside. Same thing with 6 and 7. They're on the same side and on the interior. So angle 2 and 3 and angle 6 and angle 7. Okay, now we're going to switch to the exterior. So still same side, but now on the exterior. So we can see how 1 and 4 are both on the left and on the outside. Same thing with 5 and 8. They're both on the right, same side, and they're both in the exterior. Okay. Now, corresponding is a little bit different. The definition's obviously not totally in the word. We know that corresponding, if you say something corresponds to it, it's kind of in the same spot. So that's kind of the phrase I want you to remember, same spot. If you look at the definition, it says they lie on the same side and on the same side of the other two lines. So same side of the transversal, same side of the other two lines. So here's an example of what I mean there. If you look at, let's say, 1 and 3, angle 1 and angle 3 are both on the left of the transversal and they're both above their respective line. Same thing with 5 and 7. They're both right and above. 2 and 4 are left and below, and 6 and 8 are right and below. So we have 4 examples here of corresponding. Just remember, same place. Both left and above, both left and below, both right and above, both right and below. So we can start with 1 and 3, and angle 2 and angle 4. Okay, and then we do the other side, 5 and 7, and 6 and 8. And so those are the 5 types of angles that we're going to look at today. So let's practice this for a minute. They want us to identify what kind of angle pair it is and determine the transversal. Well, it's kind of easier to go ahead and do the transversal part first and then look at what kind of angle they are. So if we look at the first one here, 1 and 5, I'm going to highlight 1 and 5. We can see that they both fall on line C, making that our transversal. Okay, we can see that 1 and 5 are on the same side of the transversal. They're not both inside, they're not both outside. We have one of each here, so those are corresponding. Okay, and I'm just going to abbreviate here. The next one is 4 and 6. So 4 and 6. We can see that they both fall on line C again, so line C is your transversal. We see that they're on opposite sides of line C, and they're both in the interior. Here's your interior, so we can say that they are alternate interiors, and so I will abbreviate it with an A and an I. Okay. Now we look at 4 and 10. So angle 4 and angle 10, so we kind of switched it up a little bit. We can see that 4 and 10 both fall on line A, making line A our transversal. 4 and 10 are on opposite sides, and they're both in the exterior. If you're confused about that, this is your interior because we're looking between lines C and D. That is your interior. So 4 and 10 are both on the exterior. So we would say that these are alternate exteriors, and we can abbreviate it with this. Okay, 2 and 9, we can see that they both fall on line A again. We see that they are on the same side of line A, and again, we know that this is our interior because we're looking between the two lines that the transversal goes through, so same side, interior. So we'll abbreviate it this way. And our last one here is 1 and 7. They both hit line C, making that our transversal. We can see that they are on the same sides. We have that down. And again, A and B are our two lines, and between, there's your interior. They're not in the interior, so that makes them same side exterior angles. So use your highlighter tools to your advantage to figure out who's your transversal, where's your interior, and then you can figure out which type of angle pair it is. Okay, so I want you to pause the video for a minute, and I want you to go to this website, and I want you to look at the relationship between the measurements of the angles when the lines are parallel and when the lines are not parallel. So take those lines, make them parallel, drag your transversal, and look at your relationship there. and then I want you to make the lines not parallel and see what happens there. So pause the video and then come back. Okay, so hopefully you saw what happened when the lines were parallel and the lines were not. What did you discover when the lines were parallel? Well, we can see that the angle pairs that we learned today, when the lines were parallel, we can see that we have angles that are congruent. And we can see that we have angles that add up to 180 degrees, making them supplementary. So we have two options there when our lines are parallel. When the lines were not parallel, we didn't have those relationships for our new vocabulary words, okay? They were not congruent, and they did not equal 180 degrees. But we did learn in lessons 1-4 about vertical angles and linear pair. And hopefully you saw that no matter if the lines are parallel or not, you still had that relationship. We still had the vertical angles, and those were congruent. We still had the linear pair, and those were still 180 degrees. So when I talk about B, them not being congruent or not being 180, I'm talking about the new vocabulary for today, those special angles we learned with the transversal. Vertical and linear pair will be congruent in 180 no matter what. So let's look at example 3 here, and we say, okay, are the lines parallel or not? Well, the way you know that is if they either tell you or they put these little arrows on the line. So that tells me that they're parallel. And so now I have angles that are congruent or supplementary, and we're going to figure out which one's which. So if I look at angles 1 and 5, I can see that 1 and 5 are on opposite sides of transversal T, and they are both in the exterior. Here's your interior. And so we can say that they are alternate exteriors, and let's abbreviate. Do you see how they're both obtuse angles? If they're the same kind of angles, then that means they will be congruent. Alternate exteriors are always going to be congruent. So now let's look at the next kind. We have angle 2 and angle 3. You can see that they are on the same side of the transversal T, and they're both in the interior. So we can say that they are same side interiors. Now, do you see how angle 2 is an acute angle and angle 3 is an obtuse? There's no way that an obtuse and an acute angle can be congruent, and so those have to be supplementary. Okay, that's an easy way for you to decide if they're congruent or supplementary. And so here are your theorems. And so all we're going to do here is do some highlighting. We know that if we have corresponding angles, then they're going to be congruent. Alternate interiors are going to be congruent if the lines are parallel. Alternate exteriors, if you have parallel lines, they will be congruent. Same sides, if the lines are parallel, they will be supplementary for the interiors and the exteriors. So before we go on to the next slide and practice, let's talk about what kind of equations you will set up for these scenarios. Remember, if two things are congruent, you will set up part equals part. Just like we did with vertical angles, just like we did when you have a bisector, things like that. Supplementary, we know, is two angles that add up to 180 degrees. So we will set it part plus part equals 180, just like we did with a linear pair. And so now you have your guide here. No matter what scenario you're given, if the lines are parallel, you can look at the slide and figure out which equation to set up. So let's just practice the congruency and the supplementary part of, do you know the vocabulary? So if we're looking for, talking about angle 3, and we want something that is corresponding and congruent to angle 3, remember corresponding means same side, same place. So 3 is on the left of line S and below. So the other angle that is left and below is angle 6. Okay, the next one, we're looking at angle 12, and we're looking for an alternate interior angle that is congruent. Okay, so we have to look for the parallel lines, and again, I don't see arrows, but they told us they were parallel right here. So we know that these two lines are parallel. So again, going back, alternate interior. Our interior is right here. And if we're looking for alternate, alternate means opposite side. So we would look at angle 13. Okay. Next one, we're looking at angle 4. And we're looking for same side interior that is supplementary. So we have to go to the other parallel line, and we're looking for same side interior. Remember, here's your interior. Same side would be angle 8. And the last one here, we're looking at angle 16. We want an alternate exterior that is congruent. So again, we go to our parallel lines, R and Q. If we're looking for alternate opposite sides, and then exterior would be angle 9. So as you're working through this, use your highlighters again to mark and say, is it opposite, same side, interior, exterior? And then when you start getting ready to set up your equations, you will use this slide here to help you set